Okay, in this topic, okay, I will explain about push down automata. Push down automata is actually in a chapter, okay, chapter 5. Okay, okay, PDA is in the chapter 5. Okay, our previous chapter is a chapter 4. Okay, where in this chapter 4, okay, we already learned about CFG. Okay, CFG in this chapter 4 is a string generator. Okay, string generator. Okay, but in chapter 5, okay, chapter 5 is a string acceptor. Okay, okay. So chapter 4 we generate string, okay, based on context free grammar, and then chapter 5 is a string acceptor, where in this chapter 5 is a machine that can recognize, okay, all string that we generate from CFG. Okay, in chapter 3, okay, chapter 3 is a final automata, okay, FA. Okay, FA is a very simple machine, where this machine has a huge limitation. Okay, so because of this limitation, so we need, okay, more advanced machine, okay, where we are introduced, okay, a next machine is a PDA. Okay, where in this machine, okay, uh, in this machine actually is a NFA. Okay, NFA is a non-deterministic finite automata plus stack. Okay, plus stack. Okay, so stack actually is a memory for PDA. Okay, the stack model. Okay, so PDA actually is a NFA. Okay, actually is NFA. Okay, plus uh, memory. Okay, but this memory is uh, this memory actually is a stack. Okay, not a random memory. So even this machine has a memory, but it still has a limitation because memory in this memory actually is a stack. So so when this memory actually in stack, so we can read, okay, we can read or we can write only at the top of the stack. So stack actually, okay, their concept actually is a last in first out. Okay, okay, this model actually still have a finite number of state. Okay, still have a finite number of state queue. Okay, and then this PDA, okay, this stack model more powerful, okay, more powerful than NFA, okay, but less power compared to Turing machine. Okay, in this machine, okay, this machine is a NFA, okay, plus stack. Okay, so this, okay, there is a state control, where state control will read, okay, will read string, okay, or input here. Okay, and then at the same time this state control also uh, doing pushing or popping, okay, some alphabet, some symbol, okay, in stack. This machine capable to remember or to count, okay, so that we can count, okay, how many A's or how many B's. Okay, so this process, okay, this counting process, so we will use a stack. So we can push, okay, for example, we push 3x, okay, so we know that number of x is 3, and then we can pop all these x, so we know that uh, the number of symbol that we pop also 3. Okay, 3 symbol we push, so 3 symbol we can pop. Okay, this example, okay, a power of n, b power of n. So this language, okay, can be recognized by PDA, okay, but is not regular. Okay, not regular means that uh, this language, okay, uh, we cannot use uh, FA. Okay, so we need to use PDA because, okay, this language, okay, we need to count, okay, we need to count how many A, and then we also need to count how many B's, and then at the same time we need to make sure that number of A and number of B must be similar. Okay, number of A must be equal number of B. So the basic idea of this recognition, okay, so in this machine we need to remember, we need to count how many A's, okay, by pushing some symbol, okay, into the stack, and then we can compare, okay, we can compare how many B's, okay, when we popping, okay, one by one symbol from stack. First we count how many A, okay, how many A, and then we read, okay, certain symbol in stack, and then after that we will read B. So we will read B, we need to pop, okay, we pop all symbol, and then we need to make sure that all symbol, okay, we pop, okay, until this stack is empty. So basically this machine can count, okay, and also can remember how many A and then how many B. Okay, if the stack is empty, okay, before the end of input, the word include more B's than A. Okay, for example, okay, we have 2A, okay, and then we have 3 B's. Okay, if we try to recognize, okay, this string, okay, so we push 2A's, okay, we push 2A's into a stack, and then when we pop this A, so we found that, okay, there is another we found that in stack already empty, okay, because we already pop two symbol, okay, but stack, okay, already empty, okay, but we still has one B, so that we can reject, okay, so we can reject this string, okay, this string is not A power of n, B power of n, because number of A is not equal, is not similar number of B. A not equal B. Okay, second situation, okay, uh, the stack is not empty, okay, at the end of input, okay, the word include more A's than B, okay. Next example, okay, 3 A's, 2 B's, okay, so 3 A's, okay, we push 3 symbol in stack, okay, and then there are two B's. We read two B's, so we pop two symbol. Okay, but in this stack, okay, is not empty. So if stack is not empty, and at the same time, okay, our input is uh, already finished, okay, so means that number of A is more than number of B.